All right, factoring special products. Now, these are for special trinomials that we can factor apart. The first one we're going to look at is the difference of two squares. So this pattern applies when, first of all, we have only two terms. They have to be subtracted from each other. We can't have an addition in the middle, okay, because you can't factor the sum of two squares. And they have to both be perfect squares. When you meet those conditions, it factors into the sum and difference of the individual square roots. So in this case, it would just be a plus b and a minus b. So if we had y squared minus 16, let's check the qualifications. How many terms are there? 2. Is there subtraction in the middle?
Yes.
Yes. Are they both perfect squares?
Yes.
Yes. Y squared is the square of y. 16 is the square of?
4.
4. So it factors into the sum and difference of the square roots. What's the square root of y squared?
Y.
Y. What's the square root of 16?
4.
4. So we get y plus 4, y minus 4. That's it. Make sense? Well, let's make it a little uglier. I'm not going to write your name. Some things even the internet doesn't want to see. Alright, so let's see. How many terms we got?
2.
2. Is there a subtraction in the middle?
Yes.
Are both terms perfect squares?
Yes.
Alright, let's see. What is x squared? What's the square root of x squared?
X.
X. What is the square root of 49y squared?
7.
7y. So we got plus 7y and minus 7y. It doesn't matter which order. You could do x minus 7y first and x plus 7y second if you want. That doesn't matter. That's how it factors. Make sense? That's the difference of squares. That's all you got to do. Okay? Now we're going to make it slightly more confusing. We're going to throw in perfect square trinomials. Now trinomials means how many terms? 3. And perfect square means it's the perfect square of a binomial. Now, we're going to look at two different versions, and the difference between them is not too complicated. So what we look for is the two ends, the first term and the last term being perfect squares. Okay? And then the middle term needs to be twice the square root of the other two terms. We did this when we were multiplying out special products. Okay, this was one of the ones we multiplied out. Now we're just working it in reverse. Now, when we do this, it factors into a plus b times a plus b, or a plus b squared. Now the other form is just a little bit different. It's a squared minus 2ab plus b squared. Now notice that both the a squared and the b squared are positive. Only the middle term is negative. If that last term is negative, you got a whole different pattern that you got to figure out. And in this case, the only thing that changes is instead of being plus, it's minus.
So the 2 is theirs for to times it.
Which 2? This 2?
Mm-hmm.
Yeah, that's 2 times a and times b.
Okay.
So let's see if we can recognize this. N squared minus 12n plus 36. So first question, how many terms do we have?
3.
3. Awesome. Now, are the first and last terms perfect squares?
Yes.
Yes. N squared and 36 are both perfect squares. What is the square root of n?
And
N. No, the square root is just n. Square root of n squared is n. Okay. What's the square root of 36?
6.
6. Now, is the middle term here 2 times n times 6?
Yes.
Yes, and with a negative, but that negative will come out in our factoring too. Okay? So, since it fits that pattern, we can factor it in a perfect square trinomial pattern, which means we're doing the square of the square root of the first, the square root of the second, What's the square root of the first term? What's the square root of the third term? 6. And then the sign in between matches this sign over here.
So the first sign.
There we go. It's actually the second sign. The first sign would be the sign. The first sign would be the sign of the unsquared, which is positive.
So you don't have to find by squaring the 12.
Nope.
You don't do anything with the 12?
No, the 12 comes from those two terms. Now, if you think about it, we could have factored this the same way we normally factor it, right? What factors of positive 36 add up to negative 12? Negative 6 and negative 6. So it would factor into n minus 6 times n minus 6, which is the same as n minus 6 squared.
So if we really forget this and we really cannot figure it out, can we just resort to factoring for at least the
In this case, yes, the factoring is the same. Yeah. Now, you
n minus 6 squared.
n minus 6 squared. Now, it's the same with these ones, with our difference of perfect squares. It's just a little bit uglier because now we're looking for factors of negative 16 that add up to 0. And we got to remember that they got to add up to 0, not to 1 or anything like that. But since we have a missing middle term, they've got to add up to 0. And so the only ones that would add up to 0 are negative 4 and positive 4. Okay. So again, we can use the same factoring patterns we use. They just get a little bit messier. So let's look at a slightly messier one. 4s squared plus 4st plus t squared. How many terms you got?
2, 3.
3. Good counting. Are the first and last terms perfect squares?
Yes.
Yes. Okay, what's the square root of 4s squared?
2.
What's the square root of t squared?
T.
What's 2 times those?
2st.
4st. 2 times 2s
Oh, yeah.
times t gives us 4st. That matches our middle term. So that means this factors into 2s, the square root of our first term, plus t, the square root of our last term, squared. Okay, and it's plus because that was plus. So those two signs there match. Make sense? Now the only thing we have to throw in there is they throw in a GCF, a greatest common factor. So notice that our first term has a 3 in it, or a negative 3. Does 3 go into all of those terms? Are you sure?
Yes. If you go into...
Does 3 go into 36?
Yeah.
Does 3 go into 108?
Yeah.
But 36 times negative 3 equals negative 1. Right?
Yeah.
We don't need that right now.
Yeah.
3 goes into 36. How many times?
12 times
12. So we're going to factor out a negative 3, which leaves us with y squared, and then negative 12y. Okay, because 36 divided by negative 3 is negative 12. What's negative 108 divided by negative 3?
Negative 36.
Positive 36. So we have a negative divided by a negative. Okay. Y squared and 36, they're both perfect squares,
Yes.
right? And what's the square root of y? Y. What's the square root of 36? 6. And it's 12, 2 times y times 6. That good? So we've got the negative 3. That's got to stay there. And we got a y and a 6. What goes between them?
Oh.
Subtraction, because
Wait,
that's subtraction.
So you don't follow from the first step where the plus is?
We follow from that one right there.
Okay.
why did we skip the multiplying? The one where it's like negative, 2 times.
That step there, that's an identifier. That proves that this factoring thing works. Okay? I just didn't write it in this one. Okay? Really what we're looking is, we got to put a square there before I forget. But really what we're looking for is, does this term times this term times 2 equal that. That's our check. It's not part of the factorization. It's what makes the factorization work. Okay?
If we're going to check this, I know how we get negative 3y squared minus 36y, but I don't know how we get that.
No, you got to make sure that if you're going to check this, when you multiply it out, you have to multiply it out like this. You can't square y and square 6. You have to FOIL out y minus 6 times y minus 6. Okay? All right. Let's do one more. Is x squared a perfect square? Yes. Of x, right? Is 1/9 a perfect square?
No.
Is 1 a perfect square?
Yes.
Is 9 a perfect square?
Yes.
So 1/9 is a perfect square.
1/3.
1/3 is its square root. Okay? 3 squared is 9. 1/3 squared is 1/9. Okay? So, does 1/3 times x times 2 equal our middle term? Yes, so this factors into x plus 1/3 squared. That's the square root of x squared and the square root of 1/9 squared. Now we want to solve this equation. What can I do to solve this equation?
You can
minus 1/3, yeah.
You can do 1/3 squared by do 1/3 squared.
No.
Can't we turn it into a trinomial and do the 0?
I could. You could split it and do x plus 1/3 times x plus 1/3 and use your zero product property. There's another step you could do.
Oh, subtract 0?
Where's that going to get me?
No.
Oh, square.
Root.
Square root.
Square root. I can take the square root of both sides. That cancels out the square on the left. And what's the square root of 0? 0. So I get x equals negative 1/3. Okay? So that's how we factor our special products, and we can use them in our equations too.
What would happen if it was like x squared plus 1/9 equals 0? Would you still?
Then we'd move the 1/9, and then we'd take the square root. Okay.
So you wouldn't move the 0 over?
No, you're trying to get x by itself, right? I don't want to move the 0 over with the x.
Okay.
And moving a 0 doesn't do much for you because it doesn't change either side. Okay? All right.